Hello guys, this video is presented by I am a chemical engineer. I am Peter Abdel Malak, junior chemical engineering consultant at MDC. This video is the first one of chemical engineering videos presented by I am a chemical engineer center. Each video we are going to discuss specific equipment or process amongst chemical engineering fields. I am a chemical engineer was originally started as a page on Facebook a year ago. We have almost 1,000 fans, chemical engineers all over the world. In this video, we are going to discuss operating principles of steam jet ejectors. Let's take refineries as an example. There are two types of distillation columns in a refinery. First, the atmospheric, and the other is vacuum distillation column. In the atmospheric tower is just exactly as the one we are seeing now, but without these steam jet ejectors. It's called atmospheric distillation tower. In the atmospheric tower, crude is heated up to a specific temperature depending on the crude type and its origin. Okay. At that temperature, you can obtain distillates, middle distillates, and residue. Distillates from the top of the tower, middle distillates like light vacuum gas oil or gasoline or something, and the residue from the bottom. Okay, so most occasions that is not satisfying enough for a refinery. They need more light products. Unfortunately, heating cannot do the trick. After a point, heating the crude under atmospheric conditions would result in thermal cracking, which means a catastrophe for a distillation column, which means that plates would be clogged by coal. Here comes vacuum distillation in handy. Vacuum distillation tower rule: whenever you reduce the pressure, crude boiling point decreases, and hence you can enhance separation without cracking. That's the main point of vacuum distillation tower. If you heated the crude, you can get a thermal cracking in your tower. So you use vacuum distillation tower, which means that you will install these two equipments here. You can reduce them to only one steam jet ejector, but most of the occasions, if you need more vacuum, you would use two steam jet ejectors. Placing jet ejector is done at the last point of your system. Let's consider that this is our system. Our distillation column is our system. So you would put the steam jet ejector at the last point of your system. This point must have only gas. It cannot contain any liquids or solids, for that matters. In the vacuum distillation tower shown, two-stage jet ejector is used in order to obtain lower pressure. The output, here are the two steam jet ejectors. The output stream of a jet ejector is most probably going to flare system. In some occasions, it's gone to the atmospheric, but it's not recommended by the environmental regulations. Okay, so then, as an addition for this system, our system, as an addition to reduce the pressure even more and to efficiently get higher separation, you can use stripping steam reagent. Stripping steam is taking the exact same rule as jet ejector. Stripping steam can reduce the partial pressure of hydrocarbon entering here, which means that by reducing the partial pressure even more dramatically, reduction of the pressure would happen by adding to our, bearing in mind that we are going to use steam jet ejector in here. Hence we are gonna reduce boiling point even more, as we discussed, that by decreasing pressure, we are increasing our ability to obtain lighter fractions of oil by reducing boiling point of the mixture. Okay, jet ejector in more details consists of two nozzles. First nozzle is for the first fluid that applies vacuum, which is usually steam and named wet jet ejector. There are typically two types of jet ejectors: wet jet ejector and dry jet ejector. Wet jet ejector uses steam as an input, as an applier for vacuum. The dry steam jet ejector uses air as the main fluid. There are two main reasons that would make you use air as a fluid, means dry steam jet ejector, over wet. There are two main reasons that would make you use wet jet ejector over dry jet ejector, which are: the first one, that it produces higher vacuum. Using steam would produce higher vacuum. The second one, and the most important one, is that air with a mixture like hydrocarbon in here would result in a fire hazard, since you would be completing the fire triangle, which is air, hydrocarbon, or any combustible matter, plus ignition, which may be here self-ignition. Okay, you can expect self-ignition or anything else, so this is not a good thing to do in your refinery. Okay, the main principle of jet ejector operation is very simple. It lies down on two simple, well-known equations, which are continuity equation and Bernoulli equation. The first one is continuity equation, which states that for a tube shaped as shown in the figure, A1 multiplied by velocity 1 would equal A2 multiplied by velocity 2. A1 V1 equal A2 V2, assuming that the density is almost constant, which is a reasonable assumption in our situation. So whenever area decreases, the velocity increases. Okay. Let's see Bernoulli equation. As we can see in Bernoulli equation, pressure and velocity have a relation with each other. Whenever the velocity increases, the pressure decreases dramatically, since the relation is between P and V square. So whenever the velocity increases, the pressure decreases dramatically. Okay, let's get back to our continuity equation. So back to continuity equation, from what we gathered, when area decreases, velocity increases. Okay, and according to Bernoulli equation, pressure dramatically decreases. Okay, so let's get back to jet ejector. This nozzle right here is where steam is introduced to the system. Okay, so as we can see, this nozzle is manufactured like this. So we can see here that its area is getting tighter and tighter. So at the final point here, it would be very low area regarding that. So the velocity would go insane. It would go very high. As we saw from continuity equation and Bernoulli equation, that would result in very low pressure. Okay. So at this point or that point, the pressure would be very low, even lower lower than our main system, which is distillation column. So the pressure here would be lower than here. So the fluid would be driven from the column to our steam jet ejector. System in our situation here, vacuum distillation. This is the main idea of reducing the pressure using steam jet ejector. Thank you, and stay tuned for our next episode from our series I Am a Chemical Engineer videos. Thank you. Bye bye.